For the next example, we're going to find the total area bounded by those two functions. And the first thing I want you to do with those two functions is graph them on the calculator and then try to sketch things. My language was a tiny bit different in the directions here. There's a reason for that. But go to the calculator, graph, and then we'll try to make some sense out of this. F of x equals 3x cubed minus x squared minus 10x. G of x equals negative x squared plus 2x. Let me see if I can get this on this one. Yep, don't say anything yet, but there is going to be something a little different. Honestly, my goal with all the rest of the examples is just to show you as many variations of this as possible. Are you getting something kind of like that? What's the issue? There's like 8 functions. No, there are 2 functions. What's the issue? There are 2 regions here. Okay, so first thing we need to do is we need to kind of sketch what's happening. And I'm going to try to use different colors to make this a little bit clearer. Okay. So we have, let's see, f of x. Oh, please don't cause trouble. We're gonna focus, right? Good. I've got f of x, it looks like that. I've got g of x, this is kind of an exaggerated drawing, but it will serve its purpose. G of x is kind of like this. I know it's not a great looking parabola, but I've got my regions. And I think you guys need to take a moment and find 1, 2, 3 points of intersection. Just second calc intersect. That'll be nice numbers. Then we're going to try to find that, and we're going to try to find that.
So these are some very nice numbers.
I think I just said that a moment ago. Oh my gosh. -2, -8, I think is the first one.
And then 0, 0.
What's that last one? So the deal is, I'm just going to use that formula, top minus the bottom. What's wrong? Okay. Do you realize that if we're in this region versus this region, the top and the bottom are different functions? Yeah. What we're going to do, I'm going to call this region, region 1. I'm going to call that region, region 2. I'm going to find the area, the area of region 1 plus the area of region 2 and add them together. So, for region 1, integrating from what to what? -2 to 0. What's the top, f or g? I think f is on the top. That's kind of why I use those 2 different colors. The f function is the top one. The parabola is the bottom one. So I'm going to say f of x minus g of x. I'll do it in a moment. Let me write out the entire thing first. Region 2. What's on the top? From what to what? 0 to 2. Top. What was that? G of x. Bottom is f of x. Okay. It's up to you if you want to do this in 2 separate lines on the calculator, if you want to try to do an integral here plus another integral, whatever. Something weird's going to happen that really is just a coincidence in this problem. It's usually not going to work out that way. But see what you can get with this one.
Wait, can you add integral?
Okay, there's nothing we can do with the properties to turn these like into a single integral. You could type in this one, plus type in that one, or just type in this one, enter, get an answer, type in this one, enter, get an answer, and then add the 2 answers together. Oh, please don't cause trouble.
Nuggets made delicious.
No? You don't have things?
Oh my god.
Are you integrating?
Yeah, I'm done.
What's the first one?
I did it in one line.
Okay, what's the answer? Should be 24. This really is kind of a coincidence in this one, but if you did them as two separate ones, you'd get 12 plus 12. It really is a coincidence that they have the same area. But we'll get 24 for this.
What a coincidence.
Oh, I subtracted.
I also subtracted.
Questions on that one?
You get 0, George?
No, I didn't subtract.
I think I take back what I said a moment ago. There's only actually two more examples we need to look at here. Anything with this? If there are multiple regions, especially when the top and bottom are different functions in different parts, you need to do two separate integrals, or more than two integrals if there's more than two regions, and add them together. Next one. We are going to find the area of the shaded region. I'll draw something and shade it in a moment. We're going to find the area of the shaded region bounded by y equals x, y equals 1, and y equals 1/4 x squared. And this is going to be that shaded region that we're going to talk about. Oftentimes, you will be given a picture already drawn for you, because it's probably easier just to show it to you rather than make you kind of figure out which region exactly are we talking about. But then we have to do some calculator work and some other things to figure out what's going on. I think what you need to do right now is you're going to type in those three functions. And I think you need to figure out this point of intersection, which will be nice, this one, and that one. And then we're going to talk about how to deal with this. I do think these are actually nice points of intersection. You may have to change your window so you're kind of zoomed in a little bit to see things a little bit clearer, maybe. Well, that one is 0, 0. You figured out this one? 1, 1. And this one? It's not.
Oh, 2, 1.
2, 1. I wonder, Obi, if you were intersecting maybe the parabola with the slanted line rather than the parabola with the horizontal line. Because I know if y equals 1, the y coordinate has got to be 1 over there. Maybe? Possibly? Okay, so top minus bottom. What's the bottom?
Y equals 1 quarter x squared.
Okay, so the parabola. What's the top?
Both of them.
I think it's a little bit different based on where we are. I think the top over here is that slanted line, but I think over here the top's a horizontal line. How do I deal with having two different things on the... Exactly. This looks different than that last problem, but the logic is actually going to be the same. I'm going to kind of split things over there. Then, I'm going to do the integral from 0 to 1. We didn't have names f, g. I'm just going to use the actual function itself. You could define things if you want. You could say f of x equals x and g of x equals 1. But just remember, we're not using calculator notation. No y1, y2, and those things. For the first region, 0 to 1, what's on the top?
Y equals x.
What's on the bottom?
Y equals
That parabola. Okay, we'll do that. Then, to that, we're going to add the integral from 1 to 2. Okay, what's on the top? What's on the bottom here? 1's on the top. Bottom's the parabola. Again, it doesn't matter if you do it in one line or two separate lines. Go find them. It should actually be a fairly small area because I think you kind of had to zoom in to see it well anyhow. Let's integrate. Oh my gosh.
Whoever did that,
Shh. Hush.
give it a go.
Just integrate, please. We don't need theme songs.
It's only bothersome if you think it's bothersome.
Are you integrating?
Yes, I integrated.
Who thinks they're done? What do you have?
I have 8 or 0.8 for your reading.
Yeah, which is okay.
5-6.
Or 5/6.
Mr. Wixer seems to have an affinity for fractions over decimals.
Right. What was that? I hate to say this, but it really actually is a coincidence. In general, this is not going to happen. I think it has something to do with the fact that it was a parabola and the line kind of gives you, there's some symmetry things going on. It really, don't expect that in general, that they happen to be the same thing. Okay, there's one other weird thing we have to look at. And we're going to call these things functions of y. Functions of y. I would. We're going to do an example and then kind of generalize what we're seeing here. I'm going to find the... Stop. Find the area bounded by x equals 3 minus y squared and x equals y plus 1. And these are functions of y. As in, I would plug in a y, I'd find an x. Do you know how to graph that bottom equation? Oh, yes, you do. Come on. Sure. Couldn't you make this bottom equation y equals x minus 1? Sure. Draw some axes. Sketch y equals x minus 1, or x equals y plus 1. And then we'll talk about how to deal with the other one. And this is going to have to be something done by hand. Yeah. Get over it. Yes, but the calculator's not really going to... We're going to use the calculator for the integration, but not for the plot.
Because we're going to have...
No, because of where we're eventually going to end up going with this. This is kind of the warm-up for the solids of revolution, where there's going to be no way around functions of y, which is why I want to introduce it here. Okay. There. A point here, a point there. You should have something like this. Of course you should. You should be able to graph lines. That's not a big deal. As for the other one, to graph x equals 3 minus y squared, I think you know the basic shape. The shape would be a what? It would be a parabola. Anyone remember what it means if it's like y squared rather than x squared?
It's like,
It's a sideways one. I'm not sure about other details, though, so I think we need to plot some points. I'm going to make a little table of values. What's the input, the x or the y? I think the input's the y, and I'm going to get out an x. So this is going to look a little weird. But let's plug in 0. What do you get when y is 0? What was that? Plugging into the top equation right now. 3. I'm not going to plot the point to those 0, 3. What should I actually be plotting? 3, 0. Okay, so I know I've got a point over here. I'm going to plug in 1, and we're going to get what? 2. 3 minus 1 squared. You're going to get 2. I'm not plotting 1, 2. I'm plotting 2, 1. Oh, and that's nice that I already see them intersecting. I'm going to plug in 2. I'm going to get 3 minus 2 squared, or 3 minus 4. That's negative 1. This is actually not necessarily helping me so much. But I kind of see a parabola starting to form there. What should I probably also plot? I think some negatives would be good. Maybe I'll plug in -1, and I'm going to get 3 minus -1 squared is +1, so 3 minus 1 is 2, which is the point 2 comma -1. -2 is going to give me 3 minus 4. That's -1, so -1 comma 2. And I think I'm going to stop because I already see them intersecting. And I'm going to get something like this. And I want to find... Oh, well, hold on. Well, oh my gosh. Oh my gosh. Oh my gosh. Minus 20.
Mr. Wexler, you've committed math sin.
Okay. We want to find...
It's got all that time.
Please focus. I need to find the area of that shaded region. Top minus bottom, what's your problem?
Both on top and bottom.
Yeah, the parabola is the top and the bottom. That's not actually how we're going to deal with functions of y.
Can we split it?
It's going to make it worse. When we have functions of y, the way we're going to deal with it is rather than top minus bottom and integrating over x values, we're going to do the right function minus the left and not integrate over x's, but integrate over y's. Let's do this one, and then I'm going to write out the rule in general for this. This is going to be the integral of, let me actually say the right minus the left, and I'm going to integrate over, I'm just going to say y values over here. What's your lowest y value?
Do you write dy?
We will. What was that? I don't think so. For my region? Here's my region. Whoa. That's like why we have the graph. It shouldn't be like -2. It is negative. Oh my gosh. It is -2. What's the highest y value? 1. What's the right function, the parabola or the line? Parabola. So I'm going to say 3 minus y squared minus what's the left? Y plus 1. And it's going to be dy. Now, when you go to the calculator, you're certainly welcome to use y as your variable, but I think it's probably easier to type in using the x because then you can use that button on the top, the xt theta n button and all that stuff. It doesn't matter what you actually call the variable, but type it into your calculator. I would probably just use x when I type things in. And let's get an area for this. Then I'm going to kind of write out one thing in general about how to deal with functions of x versus functions of y, and we'll be good with these area problems.
Mr. Wexler, would you consider this very really troublesome?
I would like an answer to this problem. 9 house.
Except it didn't work because I forgot.
By the way, one thing I want to point out that sometimes the calculators do. If you have some like really horrible decimal for this thing and some horrible decimal for that, the final answer should be like an irrational number, right? Some decimal. Sometimes the calculators try to turn those into fractions. If you do fraction, enter, enter. It is not actually that fraction. It's just how the calculator is working. I don't know why it does it like that. It's doing some rounding things and trying to turn that into a fraction. Don't do that. If the answer should clearly be an irrational number, give the answer as a decimal. I'm not sure if it's going to show up on this particular assignment, but I know it will on the next couple topics. Last thing I want to do, just sort of summarize the two types of problems, the functions of x versus functions of y, and then I think we'll be set. For functions of x, our area is going to equal the integral from our lower x value to our higher x value of whatever is on the top minus whatever is on the bottom, which is most of what we did today. Most of the homework will involve functions of x. For functions of y, your area is going to be the integral over your y values from your lowest y to your highest y of the right function minus the left function. Thank you. dy. Can do that better. dy. And this is actually kind of setting up some of the stuff we're dealing with our final two topics, where we spin things around a line, create a three-dimensional solid, and find the volume, which actually sounds a whole lot worse than it actually is. And then some other ways we can create volumes using some cross-section things. But these ideas of like integrating over x's, doing a top minus bottom, and integrating over the y's, doing a right minus left thing, will keep showing up in those final couple topics. Okay, so hold on a moment. Let me not push the power button.